Hello everyone, good afternoon. It's Simeon here. As promised, here is a video of the solutions to the application problems that we either could not do yesterday or we rushed over due to lack of time. And without wasting too much time, let's get right into it. So first and foremost, we had a brief recap saying quadratic functions are functions that are the degree 2 polynomials, and they can be in either the standard form or the vertex form. The standard form is the form written 1ax squared plus bx plus c, where the leading coefficient is a, and we know that the graph of a quadratic function is always a parabola, but it opens upward if a is greater than 0, that is if a is positive, and it opens downward if a is negative, if the leading coefficient is negative. So it will have its vertex as a minimum when a is positive, and it will have its vertex as a maximum when a is negative. And that brings us to the second form, the vertex form. So for every standard form of a quadratic function, we can write it in the vertex form, which is of the form ax minus h squared plus k, where a is the leading coefficient from the standard form, and the vertex is h comma k. And we get the vertex, the x coordinate of the minimum or maximum point by doing negative b over 2a. The b and the a's are coming from the standard form. And we get the k, which is the y coordinate of the vertex, usually the maximum value or the minimum value of whatever quantity we are dealing with. So we get that by evaluating the standard form or whatever form of the function at the h value that we have gotten. So it is usually evaluating f at negative b over 2a. Then we saw that intercepts, to get the vertical intercepts, the y-intercept, just set x equals to 0 and simplify to get y. And to get the x-intercept, you set f of x equals to 0 to solve for x. So the application problems that we are faced with here. So in most application problems, especially when we are talking about height or things like that, the vertex form will look like, if it is height, h of t is equal to a into bracket. So instead of we are using x as the independent variable now. So t minus. So for the vertex, I don't want to use h again since h represents height. But let's use p and k. So t minus p squared, then plus k squared. In this case, p comma k is our vertex, where p here will always mean the time taken to reach the maximum, to reach maximum quantity. If it is height, maximum height. And k itself is the maximum height. So for questions for quadratic models that deals with height, as a function of time, that is how it is going to look like. So the first question here, the height of a ball is given by this quadratic model, where h is in feet and t is in seconds. We are told to calculate the initial height, the maximum height, and the time taken to reach the maximum height. We know that for any motion, the initial height is usually the height when we want to begin. And when we want to begin the motion, the movement, t has to be equal to 0. So when you are told to find the initial height, it is tantamount to asking for the height when t is equals to 0. So it means this is the height when t equals to 0. And that means we want to find h of 0. So anywhere you see t, you plug in 0. So that is going to be negative 16 times 0 squared plus 32 times 0 plus 48. Notice that this is also the same thing as looking for the y-intercept. So because we are setting the variable x, or in this case t, equal to 0, and we are simplifying. So to get the initial value of the height, it is tantamount to saying find the y-intercept of the parabola of the model. And like I told you in class yesterday, it is just the c of the constant of the standard form given to you. So in this case, it's going to be 48 because 0 plus 0 plus 48 is just equal to 48. So it means at the beginning of the motion of the ball, the height is going to be 48 feet. The second thing here, we are told to calculate the initial height. That's what we've done. Second thing is maximum height. So I've told you maximum height and the time taken to reach maximum height is simply the vertex. So where P here is the time taken to reach the maximum height and K is the maximum height itself. So we remember that P, which we used to call H, is negative B over 2A. And K is simply going to be, in this case, H of P. So to get B, the time taken to reach maximum height, let's get that first. So we need to get, so basically what we are looking for is a vertex. So first and foremost, A is equal to negative 16, the leading coefficient. B is equal to 32, and C is equal to 48. So it means our P, which is negative B over 2A, will be negative 32 over 2 times negative 16. And that will be equal to negative 32 over negative 32, which is equal to 1. So what is P? P is the time taken to reach maximum height, and that is going to be 1 second. Then, how do we get the maximum height itself? So the maximum height is the K, okay, and that is K is equal to H at P, the P that we got earlier, that is H at 1. And what does that mean? Anywhere we see T in the standard form of the expression, we put 1 there. So we have the H of 1 is equal to negative 16 times 1 squared plus 32 times 1 plus 48. Don't fall into the category of students that make mistake of doing the multiplication here first before squaring it. So the order of operation requires that we find the square first, 1 squared, before we multiply it by negative 16. So 1 squared is 1, multiplied by negative 16, we have that, plus 32, plus 48, and this will give us 64. So it means the maximum height is 64 feet. Basically, what we've done is to find the vertex P, K, which we used to write as H, K. In this case, it is 1, 64. So it means if we're actually interested in rewriting the standard form of this model in vertex form, it would have been H of T is equal to negative 16. We know the vertex form is A T minus P squared plus K. So in this case, since P is 1, that'll be T minus 1 squared plus K, and K here is 64. Okay, so that is that about that. So the maximum height is 64 feet, and the time taken to reach the maximum height is 1 second. So the key point to remember here is that to find anything that has to do with the initial height, it means evaluate, or whatever quantity you are dealing with, evaluate the function at t equals to 0, because that is the starting time. And if you are asked to find either the minimum or the maximum, it means you are looking for the vertex. So you just use the same process that we use to get the vertex. Okay, so if it is a model that has to do with time and a quantity, time will be what we used to know as h, and the maximum or minimum quantity is what we know as K. Okay, so that is that. For the second question, again, is a function of height in terms of time. So NASA launches a rocket at t equals to 0 seconds. Its height is given by this model. So we are interested in looking for the time the splashdown occur. So ordinarily, if we look at the trajectory of the rocket, it means it goes up and comes down. So it starts at time t equals to 0 here. That's where it launches. It gets to its peak at this point, P, K, and it gets into the ocean at this point. So the fact that we are looking for the time the splashdown occur, it means we are looking for the time when the height is equal to 0. This is the maximum height here, maximum height. So, and it is at height equals to 0 in two different occasions, when we are launching and when it is splashing down. So we have to get the time it splashes down, it means we want to solve h of t equal to 0 for t. That's what it means. We want to look for the time for which it is going to not be above sea level, to be, to splash down into the ocean. So, and what does that mean? It means h of t, which is negative 4.5 t squared plus 27t plus 180 equal to 0. I want to solve this for t. In the class yesterday, I mentioned that there are different methods to go about this. Okay, we could factorize if it is something very simple to factorize, especially when the leading coefficient is 1. In this case, we have a value there, not even a whole number, a decimal number. So it could be very tricky to try to factorize this. The second method was converting to vertex form first, then doing what is similar to the completing the square method to find the value of t. But this is also, the values that we have here are not looking nice. So we come to the last option, which is using the quadratic formula. And to remind you, the quadratic formula that we saw yesterday is that x, in this case is going to be t, is negative b plus or minus the square root of b squared minus 4ac all over 2a. So we need to identify our a, b, and c. As usual, a is negative 4.5, b is 27, and c is 180. So we put that into the quadratic formula to get our t. So t is equal to negative of 27, because b is 27, plus or minus the square root of 27 squared minus 4 times negative 4.5 times c, which is 180 in this case, all over 2 times negative 4.5. The next thing here is just to use our calculator carefully. Okay, so be careful with your calculator. So negative 27 plus or minus square root of the square of 27, that is going to be 729. Then negative times negative is positive. 4 times 4.5 times 180, that is going to be 3,240. So just press that carefully into your calculator and don't make a mistake with the signs. All over 2 times negative 4.5 is negative 9. So we have negative 9 here. And this simplifies as negative 27 plus or minus the square root of 3969. If we add this together, over negative 9. But what is the square root of, again, another calculator work, square root of 3969 should be 63, if I'm not mistaken, all over negative 9. And the meaning of plus or minus means that we can split this into two expressions, one with plus and one with negative. So negative 27 plus 63 over negative 9, or the one with negative now, negative 27 minus 63 over negative 9. So the first one gives us 36 over negative 9, and the second one gives us negative 90 over negative 9. That means t equals to negative 4 or t equals to 10. But what is t? T is supposed to be time, and time cannot be negative. So it means this guy is not correct, but the second guy, 10 seconds, is the time that we are looking for, the time taken for the height to be 0, the time taken for the splashdown to occur. The next one, how high above sea level does the rocket get at its peak? And what is that? That is basically just asking for the k coordinate, the y coordinates of the vertex, because I've told you that talking about minimum or maximum value is just asking for the vertex, and the maximum value is usually the k that we have in the vertex, and the time taken to reach the maximum value. Maybe I should just use tm to reach the maximum value. Tm is what we used to know as h. So how do we get h? We remember h, or tm in this case, is equal to negative b over 2a. And our b is 27, so that is negative 27 over 2 times negative 4.5. So that is negative 27 over negative 9, and that is 3. So it means the time taken to reach, for the rocket to get to its peak, is 3 seconds. So we just need to find that height at the peak. So which is simply just looking for h of k. This is usually k, which is h of tm. That is the max height. Which means anywhere you see t in h of t, you substitute 3 for t. So that is going to be negative 4.5 times 3 squared, then plus 27 times 3, plus 180. And this will give us negative, don't forget, don't multiply negative 4.5 by 3 before you square it. You have to do the 3 square first. So 9 times negative 4.5 is negative 40.5. 27 times 3 is 81, plus 180. This gives us 220.5 meters. So it means the rocket will get to 220.5 meters above sea level. That's the highest it's going to get above sea level before it starts coming down. The next question, a box with a square base and no top is to be made from a square piece of cardboard. So let's have a cardboard. We have a square cardboard, and to form a box from this, we need to cut out 3 inches square from all the corners. So copy, paste. I'm assuming those are squares. Paste, paste. So in this case, we started with a black cardboard, and it's a square, so it means all the sides of the black cardboard will be the same thing. So let's say they are all x in length. So that's what we're looking for, how big of a piece of cardboard is needed. So we want to know the dimension, x by x. But to form the box, we have cut out 3 inches each from the corners. So 3 inches there, 3 inches here, 3 inches here, 3 inches here, 3 inches, 3 inches, 3 inches. So it means from a side, we've cut out a total of 6 inches. So it means we are left with x minus 6 inches for the length of the box. And for the width of the box, we are also left with x minus 6 inches, while the height of the box is now going to be this one, which is the 3 inches. So it means we have a box, an open box of dimensions L equals to x minus 6, the width equals to x minus 6, and the height is equal to 3. We are told that the box is to hold 13,872 inches, and that means that the volume of the box is equal to 13,872 inches cubed. But wait, what is the volume of a box? The volume is simply length times the width times the height. And in this case, we are multiplying this by this by this. That is 3 times x minus 6 in two places squared. So this is equal to the volume we're given, 13,872. So we need to solve this to get the values of x. So to isolate x, the first thing we can get rid of is the 3. So we have to divide both sides by 3. So when we divide by 3, so we have x minus 6 squared is equal to 46, if I'm not mistaken, 4624. That was what we got in class yesterday. We rushed over this in class yesterday. And the next thing we need to get rid of is the square. By the time it gets to the other side, it becomes plus or minus square root of 4624. So x minus 6. But I'm going to discard the negative sign here because we are looking for the dimension of a box, so it cannot be negative. So I'm going to overlook the negative side and just look for the positive square root. And the positive square root of 4624 is 68. So we add 6 to both sides. That gives us x equals to 68 plus 6, which is 74. Is this centimeter or inches? Yes, inches. So it means the cardboard that we are going to need to be able to form a box that will hold, that is, the volume will be 13,872 inches cubed, has to be 74 inches by 74 inches cardboard. Okay, and finally, this last question is a question that was not on the note I brought to class yesterday, but is on the homework that is probably due today or soon. So I believe it's one of the questions that could cause confusion in the homework set. So this is an attempt to give you an understanding of what you need to do here. So here we have a wire that is 23 centimeters long. So we have a wire 23 centimeters, and we cut it into two pieces like this. The first piece is bent into the shape of a square, while the second piece is bent to a circle. So the question says that let A represent the total area of the square and the circle. So we have A is area of the square plus area of the circle. What will be the circumference of the circle when A is minimum? So at first it doesn't look like a quadratic model, but when we start writing things together, I'm sure you also see. So let's call the length of the blue piece L, or since it is forming a shape of a square, let's call it the perimeter of the square. And the second one, the circumference of the circle, because that's the length of a circle. So what we know is that P plus C, these two lengths must be equal to 23 centimeters. But if we have a square of length L, so it means all the sides are length L. And that means 4L is the perimeter. So it means L must be equal to P over 4. So it means the area of the square, which we know to be L squared for any square, will be P over 4 squared, which is P squared over 16. Also, if the circle has a radius R, we know that circumference of the circle is 2 pi R. Then that means the R equals to C over 2 pi. I'm doing this so that I can get the area of the circle, which is pi R squared. And since R is what we have here, this is pi times C over 2 pi R squared. So, and this is going to be equal to pi times C squared over 4 pi squared, which reduces to C squared over 4 pi. Now we have the area of the square and the area of the circle. This is what we want to minimize. Using this limiting equation, equation 1, we know that A is equal to the area of the square, which is P squared over 16, plus the area of the circle, C squared over 4 pi. For it to look like what we are familiar with, we know the quadratic expression is supposed to be something that looks like this: ax squared plus bx plus c. In this case, we have two variables, p and c. To make it just one variable, and as a matter of fact, the variable that we are interested in is the circumference. So it means we need to make everything be in terms of c, the circumference. So from equation 1, we know that P is equal to 23 minus C. So if you substitute that into the expression for the area, we get area equals to 23 minus C squared over 16 plus C squared over 4 pi. Again, at first, it doesn't look like the regular quadratic function, but we can see that the highest degree we can get here is squared, and we have a variable. So we can rewrite this as, as a quadratic function that we are familiar with. So that will require that we expand what we have on the left part of the expression. So this is x or c squared. This is c squared minus 46c plus 529. You remember I told you how to expand stuff like this in class the other day. So you just do 23 minus c times 23 minus c. Use whatever method, you FOIL it out, or you use the grid method, and you get what I have here, plus c squared over 4 pi. So it's almost like what we are familiar with. And I can make it what we are familiar with by breaking it into pieces. So this is c squared over 16 minus 46c over 16 plus 529 over 16 plus c squared over 4 pi. Now I can bring the c squares together. That is c squared over 16 plus c squared over 4 pi minus 46c over 16 plus 529 over 16. And this is 1 over 16 plus 1 over 4 pi c squared minus 46 over 16c plus 529 over 16. So this is a quadratic model A in terms of C. So the variable here is C, just like we usually have f of x equals to ax squared plus bx plus c. So to find the minimum of f of x, since this is positive, we know that it's a graph that opens up. So that's a minimum. So to find the minimum, it means we are looking for the vertex. So for f of x, you know the vertex is h comma k, and h is the value of x for which this is minimum. The same thing we are doing here. We have a of c instead, where a of c, where the leading coefficient is this ugly guy, b is this guy, and c, the constant, is this guy. So to find the minimum point of the area, the minimum circumference that will give us the minimum value is just tantamount to looking for this h. You remember the formula for h is negative b over a. So it means the minimum circumference we are looking for, the circumference that will give us the minimum area, is c is equal to negative of the b that we have here, negative 46 over 16, divided by 2a. 2a is 2 times, so if we write out our a, 1 over 16 plus 1 over 4 pi, this can be simplified as, this is 16 over 16 pi. Okay, so let's do this, 16 pi, and that would be pi plus 4 over 16 pi. So this is pi plus 4 over 16 pi. And that's basically the answer that we are looking for, the circumference in centimeter. But if you like, you can simplify this further. So 2 here, 8. So this is 46 over 16 divided by pi plus 4 over 8 pi, which is the same thing as 46 over 16 times 8 pi over pi plus 4. And that is going to give us 8 in 16, 2 in 46, 23. So that will be 23 over pi plus 4 centimeters. So this is the circumference that will give us the minimum area. If you are interested in getting the minimum area itself, that is, we want to get k, we would substitute this 23 over pi plus 4 for c in this expression. And that is all for now. So I hope it helps you understand the quadratic models, because for the next class we're moving to something else entirely. If you have any questions, you can always shoot me an email and we can see how we can help clarify things. So enjoy the rest of the week. We'll see you in class on Friday.